Welcome. Today we'll explore how a DC generator converts mechanical energy into electrical energy. Step 1 involves creating a magnetic field using a powerful magnet, either a permanent or an electromagnet. In Step 2, we mechanically rotate the armature, which contains a coil placed within the magnetic field. Step 3 is where electromagnetic induction occurs. As the armature turns, it causes a change in magnetic flux. According to Faraday's law, this change induces a voltage, or electromotive force, in the coil. In Step 4, a commutator and brushes manage the direction of the induced voltage to ensure consistent current flow. This process results in the direct current, DC, which powers various electrical devices. To summarize, mechanical energy rotates the armature, creating an electromotive force through magnetic induction. The key formula is E equals B times L times V, defining the induced voltage based on magnetic density and armature speed. Thus, a DC generator transforms mechanical energy into electrical energy effectively through these steps. And that's how a DC generator works, providing us with a reliable source of direct current for our needs. Thank you for joining us in this exploration of DC generators. Keep curious and stay inspired.